then we'll move on to making our own character. Cool. So to do this, I'm going to duplicate the scene that I already have. Yeah, I'm going to duplicate the scene. I think that'll work for now. So for this, oh, I misspelled title. Nice. So we have Forest World right here. I'm going to duplicate that one and just press Control or Command D. And then I'll call this one Custom Movement as our world. Cool. And I'm just going to not save this scene because I don't want any of those changes we made. Okay. So we have this. For anyone who's new, possibly, and wasn't here to the previous workshops and wants to follow along, since we haven't published ones, what you can do to get a quick scene up and running is press Create, 3D Object, and then make a plane. And that will give you a plane, and your object can stay on this plane as well. That's how we started out on our first workshops, if you guys followed along with the video tutorials. But if you didn't, and you're just dropping by, this is going to be a way to at least have a way to look at everything. Cool. Okay, so let's brainstorm a little bit how we're going to tackle moving our character. So, quick overview of what Rollerball currently does. With our Rollerball, whenever we press our arrow keys, or W, A, S, and D, we add forces in the specified direction. So, pretty standard. We push our ball where our keys correlate to. This is great, but there are definitely some issues to it when doing movement that's not ball related. So for instance, if I were to push a person, they are not going to keep rolling until they stop eventually. They're probably going to slide along the ground or do something along the lines of that. So rolling is not always a good corollary to all types of movement, although it is fun. In addition, with our current rollerball, when I press play and look at the scene, when I go forward and then backwards, it takes a long time for the direction to change. So it's good, it's very cool, and it makes sense for a ball, but it doesn't make sense for everything else that we'll be working on. So there's a couple ways we could handle this. First off, as we all know, whenever we look at our objects, so if I click on our rollerball, we all know that every game object has a transform. So we could essentially go into our code and take the transform values and just modify them ourselves. So we can say, okay, we want it to move forward, and just start moving the ball forward using the transform directly. Just like that, you know, but we would do it with code instead of my finger. That works. However, there's a few inherent issues with this that make it a pretty difficult method to implement. So whenever you start moving an object with its transform, then that means that you are bypassing the physics system to move the object. So whenever we do that, that means these nice things that we get. So for instance, when I play the game and I roll forward and hit this wall, we lose all of that. So all those collisions and all those bounces and forces that we were getting before, those all disappear when we start trying to move things with only the transform. And that means all of the effort falls on you because you have to do all of that now. So doing that is by no means trivial. It takes a good amount of work to make something like that actually function and feel nice. So we're going to opt for the easier path and do our movement with the rigid body and sort of tie it into Unity's physics system so we get all those nice collisions. Cool. So I'm going to turn off my rollerball for now. And let's go ahead and make ourselves a new character. Sound good? Okay. So what I'm going to do is I'm going to do create, and I'm going to do 3D object, maybe make a cube. Okay, looking good. Might just drag this one over to the middle here, drag it up a bit. So I actually know exactly how tall I want this cube to be. What you can do is you can go to the Y scale and press 2. It's going to make it 2 units tall. And then I know that to place it directly on the ground, I have to put Y equals 1. But I sort of actually like starting my character in the air, so I'm just going to start it in the air a little bit, just like that. So dragging this box over, I did a scale of 2 in the y direction. You can do whatever you like. I just think this one works out well and generally fits the size of a human as a general statement. If we were being perfect, I would probably actually suggest using a capsule collider, but it is much more difficult to see rotation when using a perfectly spherical thing. Cool. So we all have a box. Works pretty well. If we press play, it does box things. It doesn't fall. So that's our first issue that we see. There's no physics being acted on it. So to do that, we're going to do add component and type in rigid body just as we did before. Now we do that, and then we press play. It will fall down. It has physics now. Great. So that's first step down. We have physics enacted. And yeah, that works pretty well. So what we now need to do is start adding in the behavior. So I'm going to go into my scripts folder and create a new script. So I'm going to do right click, go up to create, and do C# script. If you don't have a scripts folder, no worries, you don't need it, just for organization. So I'm going to call this script custom movement, and then double click on it to open it. Cool. So we've got a bunch of other ones. I'm just going to turn those off. Any difficulties getting to our custom movement script? Nope. Cool. Okay. So let's see what we have here. So first off, actually I might just leave these back in. So we have void and update, or void start and void update. That's great. If you guys remember, start is when the game starts, update is every frame. So if we think about it, what we first need to do is we need access to that rigid body. So we need to add forces to it and move it. So let's do that first. So we're going to type in rigid body, RB. Rigid body is the type, RB is the name we're going to give it. And then the start method, we're going to do RB equals get component, angle bracket, rigid body. So we're going to get the rigid body that's currently on this object. So there's actually an implicit this right there beforehand. So for this object, whatever we put this script on, grab its rigid body. Grab the thing that handles all of its physics. Golden. Okay. And this is a small change, and it won't have much effect, but I'm going to do it really quick. We're going to change update to fixed update. The reasoning for this is that usually for all your physics-related code, you should put it in fixed update instead of update. So usually when you're writing larger scripts, you'll have both an update and a fixed update to handle different things. In this case, we're going to do it in physics update, fixed update, because we're doing physics. Awesome. Okay, so first step. I think I went over this in the extra portion of our first workshop, but I'll write it down again. So first step, we need to get movement from our character. So, quick overview of how that's going to work. We have our axes right here. We can think of these as the up arrow key, or W, right arrow key, left arrow key, down arrow key. Let me make sure I get this right, ASD. We got the A key, the D key, and the S key. So we want to correspond us pressing those keys to these directions. So if I press W and D, I want to get an arrow that points like that. So how are we going to do this? The nice part is that Unity gives us a great way to do this by default. So we have two axes here. We have our horizontal axis right here, H, and we have a vertical axis right here. So that's pretty intuitive. This one goes up and that one goes right. So Unity provides us a way to get these axes. So if I'm getting the horizontal axis, what's actually going to happen is it's going to return a value between 1 and -1. And if I'm getting the vertical axis, it's going to return between 1 and -1, depending on which keys you're pressing. If you're pressing nothing, you're going to get 0 on that axis. Cool, so let's get it. Let's get that input. So since it's between 1 and -1, we know that it probably has to have decimal points, otherwise we're only going to have 1, -1, and 0. So that means that we need to use a floating point number, or a number with decimals. So we're going to type in float, and then I'm going to get the horizontal one first, so horiz equals, and then we're just going to type in input with a capital I dot get axis, similar to how we were talking about before, and then inside of it put horizontal in quotes. So this is something built into all Unity scenes by default. So by default, when you press A and D, horizontal is going to return how much you're pressing of each one. And we'll do the same thing with vertical. So I'm going to type in float vert equals input dot get axis vertical. So now those should be returning values between -1 and 1, depending on when we're pressing it. Any questions on this input stuff? It's not the most intuitive, but seems like it's pretty good, everyone. Cool. Okay, so now what we need to do is we need to move the character based on these inputs. So the way we're going to do that is with a function called move position. So previously, we would get this arrow. We can imagine this is the ground. And then we would say, push our character in the direction of that arrow. And that worked fine. That was pretty cool. I actually liked it. But when you're adding forces, that means that it sort of starts carrying a momentum, and it's going to start moving and having this stuff that makes it difficult to move it one direction or another. With move position, which is another way to handle it, that means that we actually just take our object and just move it a little bit. So that actually ends up working out great because we can move things very snappily, but we still get all that collision from the physics system that we did previously. So let's go ahead and do that. So we have our sort of two inputs right here. I want to correspond this into an arrow or a vector. So we're going to type in vector 3 for a three-dimensional vector. And then we're just going to call it movement vec equals new vector 3. And inside of it, we need to put 3 values. So you can imagine that here, the arrow coming out of the board is going upwards in the world. And then these two, this one's going forwards, and this one's going to the right. So we actually want to move our character on this plane. And the way it works is that this axis right here is the z-axis, and this axis is the x-axis. And the one coming out of the board is the y-axis. So this is different than math classes. We are using a different coordinate system. Sorry, it's a little bit confusing. But the way it's going to work is we're going to take horizontal and assign it to x. So we're going to put horiz for our first one. We're going to assign 0 to the y one, because we don't want to move it up at all. And then we're going to assign vert to the forward one, to z value. Sweet. Okay, that works out pretty well. So now what we want to do is we want to type in rb.movePosition. So take our rigid body that we have, rb, and we're going to move its position. So the first way I would tackle this in my mind would just be typing in movement vec. We just got this movement vector. That seems like it would work pretty well. However, that's actually not going to work out perfectly. And if we go back and test it, we can see why. So if I go in to this, we have our character here. We're going to add our script onto it. So I'm going to add component, and we're going to type in custom movement. Or you can just drag and drop your script onto it. like that. I just like typing it. It's a little bit faster. And let's test it. Let's see what happens. So if I press, whoops. So if I press play, it's going to start getting jittered around and acting very oddly. And if I press forward, it'll move forward a little bit. And if I press back, it'll move around. I have a little bit of control, but that's definitely not what we're looking for, to say the least. I don't think we can make, I mean, let me not underestimate you guys. You guys can probably make a really cool game with this. I can't. I can't think of a way to make something interesting with this. So let's figure out what's going wrong. So going back to this right here, we're putting in move position, we're putting in this movement vector. However, move position is actually expecting a position in the world, not a direction. So what we need to do is we need to add our movement vector onto where we currently are. That way we keep incrementing wherever we're going. So the way we're going to do that is we're going to get our current position using, so I'm going to type in this dot transform. So getting our transform, which, as you guys remember, has position, rotation, and scale, and then just grabbing the position part of it. And if I type in position again, you can see it is a vector 3. So that works out well. We're adding 2 vector 3s, and that works out. Position, and then just do a plus like that. So let's try out that. And there's this right here in the front. The this is optional. Cool. So let's test that one out. We get into it. Oops. Okay, so we're there. Let me press left. Okay, moving fast. A little bit quick. A little bit speedy. A little bit speedy, to say the least.